In this video, I'll cover the first half of the fall of 2019 exam 3 for MA162. So first question, when you look at this, you should be able to tell that it's a geometric series of something like this. So then you can use the summation formula of sum equal to a over 1 minus r. In this case, a is 1, and r is a fifth. And you should get 1 over 4/5, which is 5 over 4, and you should get C here. All right, second question, it's asks about the telescoping series, but this does not look like a telescoping series yet, so you can transform this using partial fractions. So give some variable to both of these fractions and try to solve for a and b here, in which you could multiply things out. Which this should be 2. So you will notice that there is no n on the right side. So it would be am plus bn equal to 0, as there's no n on the other side. And the second equation would be 3a plus b will be 2. So when you solve this, you can say for this, divide n on both sides and move a or b over, then you will get a equal to negative b or b equal to negative a. And you can plug this back in here, in which it will be negative 3b plus b equal to 2, and negative 2b equal to 2, and b equal to negative 1. In which case, when you plug this back here, then a will be 1. So you will have in that case, you would have a so 1 would be here, and sorry, negative 1 would be here, and 1 would be here. So then this will be a telescoping series. Wait, hold up. That's not right. It should be negative 1 here as it multiplies out. So then you can write plug 1 in and plug in some values in the first couple in the series and see if you can see some convergence. So I'm just going to plug 1 into here. It should be 2 because 1 plus 1 minus a fourth. And now you plug 2 in, you get 1/3 minus a fifth. Then you plug 3 in, you'll be plus 1/4 and minus a 6. And you can see here 1/4 actually cancels out with this minus 1/4 here, but we can keep going. As we see, when you plug 4 in, you will get 1/5 minus a 7th. And just gonna plug one more in for the sake of it. Plugs 5 in, you will have plus 1/6 and minus 1/8. And here you can see that a fourth cancels out. The 6 cancels out, 5, and so on. So you would, and later it would cancel out 1/7 and 1/8. So you're left with a half plus a third, which will give you 5/6. And yeah, the first two are C and C. Then we get to this. This fraction here might be a little messy at first, but so we can do comparison as all the options are basically comparison, which except for that one. So we can first see what these two series converge or not. So first of all, when we look at this, you can make this into a half over m, as negative m brings the the fraction, rather the number down below, and then it will be this, and then you can take the m out of these into this, which would be a geometric series. And we know that geometric series with r is less than 1 will converge, and a half is less than 1. So this will converge, this series. Um, so, and then when we look at this, we can use the divergence test. So, we take the limit of m to infinity, then we can have this, and this is not 0, as the cosine of anything range, no matter what it is between 1 and -1. So this value is fluctuating between 1 and say this value 1 and 1 1/3. Sorry, it should be the wrong side. So this does not converge, since it does not pass the divergence test, as when you take m to infinity, this is not 0. So with those information, we know this diverges, this series, and this converges. So when you look at this, when you compare a convergent series with any series, it can only tell you that it's the series you're comparing to is either convergent or it's inclusive. It's not applicable. So when you compare the series to a convergent series, there's no way you can get a confirmed divergence out of the test. So this is B is automatically out. And same goes to C, as you comparing to a divergent test, a divergent series, and there's no way you can get the result of convergence. And then so that leaves us with A or E technically. If none of those work, then we would choose D. So and then let's try comparing this to this, since it's a little bit easier. And we can do either a direct comparison or limit. I think it is fine, but I'm gonna use direct comparison here. So we can see that first, let's write the series out. There's this, and the actual series of here. And from just looking at this, since we said that this in the bottom here is gonna be between, um, so when you pull this out, this should be just this series times this series, and we know that this series is between 1/3 and 1. So no matter what the value are, a third, and between 1/3 of 1, it will always make this whole series less than this series right here, since it's dividing it technically by some number. So it will always be smaller than this series. And by comparison test, this is a convergence series. So so it will be this series will be convergent since it's always smaller than this series. So E will be the answer. And when we compare it, if you're wondering for A, when we compare it with this series, it's the same reason as this will always be smaller than 1. So when you compare it to a divergent series and it's smaller than a divergent series, it will tell you nothing. The test will be invalid, and then it won't tell you that it's divergent. Let's move on to 4. So for A, for 1, you can compare it to, you can use the direct comparison test or the limit one, comparing to this. And from looking at it, we can see that this series will always be bigger or equal to that series, or because it should be just bigger in the long term, because you are -1. When you -1, it makes the denominator smaller, which in turn make the fraction bigger. So if you have like a value of 10 for k, then it would be 20. For this series, then it would be 1/20, and this will be 1/19, and 1/19 is bigger than 1/20, and this is a divergent series, um, because it's basically 1/k, which is divergent, due to when you learn p series and stuff, it is divergent. When p is more than 1, then it's convergent, but when it's less than 1 or 1, then it's divergent. So this series, since it's when you compare it, it's bigger than a divergent series. This is in turn divergent and not convergent. And looking at this, immediately you can tell this is an alternating series. So when you test this, you should think of the alternating series test, in which we have like alternating negative positives, and then there's the two criteria you need to meet, which is the limit of this thing uh, is going to 0, and that the terms have to be smaller. It gets smaller as you go. So let's see if this meets those two terms. So definitely when we take the limit of this, it's k. You don't have to consider the negative part, as you're just taking the limit of the series. That the values actually matters. So when you take this to infinity, then this will be infinity big. So then, since this is the denominator, so this will be infinity small and approaching 0. So it meets the first criteria, and the second criteria is the values get smaller as the terms get larger, and we know that since 1 over root k plus 1, as root k as k gets bigger, root k gets bigger too. Say the next term is this. Root k gets bigger, then this is in turn smaller as it's in a denominator, and the bigger the denominator gets, the smaller the actual value of the fraction is. So it meets both terms of the alternating series test, then the series is convergent. And then this, similar to series 1, you can compare this to 1 over k squared, and thus, since it's a p-series, it converges. And when you compare it to the actual series, it's a little smaller since it's plus 1 and the denominator is getting it's bigger. In turn, the fraction is smaller. So when you're direct comparing to a series that is convergent and is smaller, then that makes the series convergent. So it should be choosing D here. Um, and for 5, this should be pretty easy when you use the alternating series estimation theorem, as your error is around is 6 to the negative 7th, which you can change that to 1 over 6 to the 7th. And looking at this, you can tell the 7 is here, and the 1 is on top. It's just alternating since it's negative 1, 1, negative 1. And the error, you just take the absolute value, so you don't have to consider the negative up top. So the n will be 6, as it's the n here will be 6, and the smallest number of n such that the error is guaranteed is one less than this, since the alternating series estimation theorem tells you that the sums uh, is actually just this minus plus 1, and we know that the error is this much. So then n equal to 6, then you're finding this n will be 5. You should always be able to get the alternating series estimation, since you should be what the error should be one term more than the number they're looking for, and you just have to be careful of the wording on, like, are you finding this term or are you finding the error? Move on to question 6. So here, uh, I wouldn't worry too much about this. I think you can just do root tests, and then something around the lines of limit chain rule, and then you can get something like uh, after root test you should get something like 1 over r, and then since r is more than 1, the fraction will be less than 1, then the root test satisfies, then this converges. But if you don't know how to do that, that is completely fine, because when you look at b, uh, it's just basically a comparison test, and it's saying that you have a series A and series B, and that if series A is convergent, then B is convergent. But when we see the comparison here, A is actually less than B, and that's not how comparison tests work. B has to be smaller than A in order to show that B is also convergent, because the known here is A, not B. If it's switched, like uh, if you know that B is convergent, then you can say that A is convergent, but the vice versa doesn't work here. So this is all just false. But here, the same comparison between the two series, then if A is divergent and B is bigger, then this works. That's how comparison for divergent works. So this is true. But since we know B is already false, you don't have to worry about any of these. So like make sure that you know if you don't know something, try to do the other ones and see if you can find the false. And just talk about the other stuff. So D, I think you can just compare this to a P series. Wait, yeah. So it'd be this is a P series since it's more than one, then this should converge. And then it's since it's gonna be a little bit smaller, since the denominator is a little bigger, then when you compare these, this should be convergent. And this is divergent as the geometric series one. So if R is less than one, then it converges. If it's more than one, then it diverges. So that's the first half of this exam. I'll cover the next half in another video. And if you have any questions, leave in the comments. Thank you. Thank you for watching.